Hello ladies and gentlemen. Today we are going to start new topic trigonometric ratios. Before we start, we have a do now question which is related to our previous topic similarity. Remember that, ladies and gentlemen, if we have angle bisector which is AC, then you can compare the side with its base. So which means that 12 over x is going to be equal to 27 over x plus 5. After setting up your proportion, you can use cross multiplication. Before that, I would like to simplify 12 and 27 by 3. 12 divided by 3 is going to be 4. 27 divided by 3 is going to be 9. Now we can use cross multiplication. 9x is going to be equal to 4 times x plus 5. If we distribute 4 into the parentheses, 9x will be equal to 4x plus 20. If we subtract 4x from both sides, you can get that 5x will be equal to 20, x will be equal to 4. Am I done? Not yet. Because the question is asking you what is the length of the BD. If we substitute 4 into the x, you will find the length of the BC is 4. You will find the length of the CD is 9. So the length of the BD will be equal to 4 plus 9, which is equal to 30. This is the answer. Today, as I mentioned before, we are going to go over trigonometric ratios. In this topic, we are going to learn 3 important trigonometric ratios: sine, cosine, and tangent. Before starting our topic, the most important thing you should know is to be able to find the trigonometric ratios, you need to have right triangle. Let me draw a right triangle. If you have a right triangle which is A, B, C, let me say that the length of the CB, which is opposite of angle A, is A. The length of the AC, which is opposite of angle B, is B. And the length of the AB, which is opposite of angle C, is C. These ABC are length of sides. Let me determine an angle, because to be able to find the trigonometric ratios, you need to determine an angle. Let me say that the angle alpha. According to angle alpha, A is called adjacent side, B is called opposite side, C is called hypotenuse. Now let's find trigonometric ratios. The first one is sine function, sine alpha. Sine function can be calculated the ratio of opposite side over hypotenuse. What was the opposite side? The opposite side is B over, what is the hypotenuse? Is C. So B over C is going to give you the ratio of sine alpha. What about the cosine alpha? Cosine alpha is adjacent side over hypotenuse. What is the adjacent side? Adjacent side is lowercase a over hypotenuse is lowercase c. The last one is tangent alpha. Tangent alpha is opposite over adjacent. What was the opposite side, which is B, over what is the adjacent is A. On the other hand, you should also know that tangent alpha can be calculated sine alpha over cosine alpha as well. We are going to use this information to be able to find trigonometric ratios. Next slide. In this part, we are going to find sine, cosine, and tangent ratios for angle H. So this is the angle I need to find trigonometric ratios. So let's get started. Remember that sine angle H. What was the sine function? Opposite over hypotenuse. What is the opposite side of angle H? Is 12 over, what is the hypotenuse? Which is 15. If you simplify this by 3, you can get that 4 over 5 is your answer. What about cosine H? Remember that cosine function can be calculated adjacent over hypotenuse. What was the adjacent side, which is 9? Most of the students are confused here. The adjacent side of the angle H is 9 or 15. Remember that, ladies and gentlemen, the side which is opposite of 90 degree is always the longest side, which is called hypotenuse. So this is the reason adjacent side is 9 over hypotenuse is 15. If you simplify by 3, you can get that 3 over 5 is your ratio. The last one is tangent H. Remember that tangent is opposite over adjacent. What is the opposite side? Which is 12 over opposite side over adjacent side, which is 9. If you simplify this by 3, you will find that 4 over 3 is your answer. Next slide. Now, first is in this question, the length of the A, B, and C are given to you. We will plug these numbers into the ABC first, and then we are going to determine our angle. Look at this here, ladies and gentlemen. Our angle is A. So whatever you are going to get the trigonometric ratios, you will take it according to angle A. So first, let me plug in. The length of the A is 8. The length of the B is 15. And C is 17. After that, my angle is going to be angle A. Let's start from sine function. Sine A, remember that sine can be calculated opposite over hypotenuse. Opposite side is 8 over hypotenuse is 17. 8 over 17 is your answer. What is the cosine A? Cosine function is adjacent over hypotenuse. Adjacent is 15 over 17, and this is your cosine ratio. And the last one is tangent. Tangent A is, what was the tangent? Opposite over adjacent. Opposite side is 8 over adjacent is 15. 8 over 15 is your answer. And these are the trigonometric ratios of sine A, cosine A, and tangent A. The next slide, which is the last slide, we are going to find the trigonometric ratios for 30-degree, 45-degree, and 60-degree angles. Remember that, ladies and gentlemen, 30, 60, 90, and 45, 45, and 90, there are two important special triangles. I am going to start first with 45, 45, 90, and then I am going to prove 30, 60, 90. Let's get started. This is your 45, 45, 90-degree triangle. This is, on the other hand, this is also a isosceles triangle. If I say that, let me say that this is a triangle ABC. If I say that the length of the AB is A, then you can tell me that the length of the AC is A as well. And what is the hypotenuse, which is BC? A times radical 2. We already proved this in our previous lesson, so that's why I'm not going to prove it again. I will use trigonometric ratios by using one of the 45-degree angle. It doesn't matter which angle you are using, B or C, they are same 45-degree angle. So I would like to use the angle C. Sine 45. What was the sine? Opposite over hypotenuse. Opposite side is A over, what is the hypotenuse? A radical 2. When you simplify the A, you will find 1 over radical 2. In math, we don't leave the denominator with the radical sign. This is the reason we are going to multiply both numerator and denominator by radical 2. After that, radical 2 times 1 is radical 2. Radical 2 times radical 2 is 2. This is going to be your trigonometric ratio of sine 45. Next one is cosine 45. In the cosine function, you can find the ratio by adjacent side over hypotenuse. Adjacent side of the 45 is A over the hypotenuse is A radical 2. When you simplify this, you will find 1 over radical 2. Remember that we don't leave the denominator with the radical sign. This is the reason you are going to multiply both numerator and denominator by radical 2. Then you will find radical 2 over 2 is your answer. The last one is tangent 45. What was the tangent? Tangent is opposite over adjacent. Opposite side is A over adjacent is A. When you simplify this, ladies and gentlemen, you will find 1 is the trigonometric ratio of tangent 45. All right, ladies and gentlemen, next part is 30, 60, 90 degree. If you try to draw a triangle, right triangle, special triangle, 90 degree, 30, and 60, we know that this side which is opposite of 30 is shortest side, which is, let's say that A. And then this side which is opposite of 90, which is hypotenuse, will be 2 times A. And the side which is opposite of 60 will be 8 times radical 3. We already learned this in our previous topic, so that's why I'm not going to go over one more time. This is the property of triangle 30, 60, 90. Now, I am going to first start with the angle 30, sine 30. Remember that sine function can be calculated opposite over hypotenuse. The length of the opposite of 30 is A over hypotenuse is 2A. When you simplify A, you will find that 1/2 is the trigonometric ratio of sine 30. Next is cosine 30. cosine function can be calculated adjacent over hypotenuse. Adjacent side is a radical 3 over opposite side, hypotenuse is 2a. When you simplify the a, you can get radical 3 over 2 is always the trigonometric ratio of cosine 30. The last one is tangent 30. Tangent is, remember that, opposite over adjacent. Opposite is a over adjacent of the angle 30 is a radical 3. When you simplify a, you can get 1 over radical 3. Remember that we can't leave the denominator with the radical sign. This is the reason we are multiplying both numerator and denominator by radical 3. Then you will get radical 3 over 3 is the trigonometric ratio of tangent 30. Next, we are going to focus on cosine, sine, and tangent 60. This is my angle. Let's get started with sine 60. Sine 60, remember the sine function. Sine is opposite over hypotenuse. Opposite side is a radical 3 over hypotenuse is 2a. When you simplify the a, you can get radical 3 over 2 is the trigonometric ratio of sine 60. Cosine 60 is, cosine function is adjacent over hypotenuse. Adjacent side of the cosine 60 is a over hypotenuse is 2a. When you simplify the a, you can get 1/2 is trigonometric ratio of cosine 60. The last one is tangent 60. Tangent function is opposite over adjacent. Opposite is a radical 3 over opposite side over adjacent, which is a. When you simplify the a, you will find radical 3 over 1. The only thing I am asking you to notice here is sine 30 is equal to cosine 60, cosine 30 is equal to sine 60. And this is the end of our lesson.